Hello and welcome to the Counting the Earth podcast from the UK Centre for Ecology and Hydrology. I'm Alice Hope.
And I'm Sue Nelson. Throughout this podcast, we explore the environment and the natural world, but always through the lens of one number.
In this episode, we are focusing on drought. So it might come as a surprise when I tell you that our headline number is 90, as in 90%, which is the percentage of the UK's expected average rainfall that actually fell here last year in 2025. Not much of a drought there then, it would seem.
Not so fast, Alice, as later we'll be talking to UKCEH hydrologist Lucy Barker about the complexities of the UK's weather and water cycle that's hidden within that overall number.
Now, we should stress that low rainfall or heat waves don't necessarily mean a drought. Lack of rainfall is known as a meteorological drought. But there is more to the country being in a drought than a long dry spell. And what we're interested in today is drought across the whole water cycle, when there are shortages across everything from low reservoirs or groundwater reserves to low river flows and low soil moisture. In other words, parched, dry, cracked ground.
It was in pursuit of that last measure, soil moisture, that at the end of 2025, Alice and I pulled on our wellies, wrapped up warm, and headed off into the Oxfordshire countryside to take a look at a UKCEH-run monitoring network named Cosmos UK, which uses a surprising method to measure the water levels in our soils. Our guide was micro-meteorologist Dr Jon Evans.
Okay, so this is the entrance to Churchfield with the Cosmos UK station you can see on the hill there. And we just go through into the field.
The field looks in very good condition considering it's December. It's so lush and green with the grass beneath our feet. And in the distance there, what looked like a series of stone or wooden poles. I can see a couple of solar panels and some other interesting devices, which no doubt you'll fill us in on as soon as we get a bit closer.
This is one of a network of 45 stations across the whole country, and we have those located so that we capture the range of climate and soil types as well as different types of vegetation.
Okay, Jonathan, we've reached the station. It is a bit of a hodgepodge of instruments. What are you actually doing here?
We've been working here since 2011 at this site at Chimney Meadows, and we've really developed the use of the technology for measuring soil moisture that we call Cosmos.
You've said Cosmos, so I immediately think galaxies, stars. What do you mean by Cosmos?
Cosmos is actually short for Cosmic Ray Soil Moisture Observing System, which is a bit of a mouthful. It is essentially measuring how much water there is in the soil.
Hold on a moment, you said cosmic ray. You can't let that slip by.
It sounds like something out of a sci-fi book, doesn't it? So absolutely. How do cosmic rays help us understand the soil?
Cosmic rays come from deep in space. They actually generate what we call cosmic ray neutrons in the upper atmosphere. And those neutrons, they're around us all the time, moving through us and through the soil. And they interact very strongly with the hydrogen in the soil water. So the little neutrons, they're bouncing around off these hydrogen atoms or protons, and you can imagine this as subatomic billiard balls, if you like. And how many neutrons come back out of the soil depends on how wet it is, how much hydrogen there is in the soil.
So there is this connection, obviously, then, with the cosmos and soil moisture, which is incredible, because I always thought neutron was a neutral particle. That's one of the reasons it's called a neutron, isn't it?
Yeah, and that's a really good point, because actually the fact that it's neutral actually makes it harder to measure because it's not charged and there's no magnetic field. These are properties that we can often use to detect a particle. But neutrons are neutral, and we have to use a more specialised technique which comes from nuclear physics, where if you have the right type of atoms or nuclei, they can capture a neutron, and then that generates an electrical pulse, and we can count those pulses.
We've got some instruments on a tripod. We've also got some things which, in the nicest possible way, John, look like tin cans on poles. What are we looking at?
We're looking at research grade weather station instrumentation. So we have at the top here this lovely blue instrument with the black transducers. This is measuring wind speed, but it doesn't only measure the horizontal wind speed, it measures wind speed going up and down as well. And we can use this along with its measurement of air temperature to estimate the evaporation from the land surface.
Well, let's move further along towards a couple of solar panels.
The solar panels power the whole site, all of our instrumentation, and including a wireless router that sends all the data back in real time. So everything's accessible publicly and freely available, all of the data.
Okay, which is Cosmos?
This rather elegant white tube here.
It's about just over a metre in length, maybe a little bit longer than that. About the width of my hand, white, tied up behind the solar panels. This is not what I expected.
No, it's quite novel for soil moisture instrumentation. You might notice it's not even really touching the ground. We can use these properties of the neutrons that I was talking about. The fact that they do move all around us means that effectively the signal comes to us. So the neutrons are scattered from all around us in the field. They measure over a really large area from up to 200 metres away from us, and that's one of the key...
What, just that this thing here measures up to 200 metres away?
Because you could have a neutron from over by that fence over there, could be scattered and hop along and reach the detector here.
So the detector's inside this?
Yeah.
And the neutrons go through the metal casing onto your detector?
Yeah.
That's amazing. You don't think about there being these things moving around that you can't see. It's very almost difficult to conceptualise the idea that something could travel through a metal tube like that to us seems impenetrable, really.
Yeah, and it gives us this great ability to remotely sense the whole surrounding field. So instead of having traditional soil moisture sensors, which probably would be in the form of buried probes that you walk across there and you stick in the grass or bury in the ground, and they'll be right in the farmer's way whenever they want to cut the hay or whatever. Instead, we can be in the middle of the field and just have one sensor that does it all, really. What we can also do is have multiple detectors. So with this size of detector, we'll get a good reading for the whole field once a day. If we wanted more frequent data, we would have more detectors, and we can have them in a mobile mode. So you could put them in the back of a truck, have 10 or 12 detectors, drive around and map soil moisture. And other colleagues in Germany, for example, put these on trains as well, particularly on slower moving freight trains to monitor soil moisture along those larger areas.
We have lots of measures for drought as well, like rainfall and river flow and reservoir levels. So what does knowing soil moisture add to those measurements?
Soil moisture is really important in that it's a storage of water, and it does obviously reflect how much rainfall we've had, but it also reflects the underlying conditions in terms of drainage and groundwater conditions, as well as how much water evaporates from the land surface. So the current soil moisture content is a combination of all of those things, and it really helps us understand the conditions for drought risk or the continuation of duration of drought intensity.
Presumably, soil moisture is really, really important for agriculture as well.
Absolutely, yeah. So this is one of the key potential benefits, so that we can understand better the availability of water for crops, and if farmers might need to adjust cropping patterns or the types of crops they grow.
Now, we've discussed drought. What about the other side of things with flooding? Because soil moisture must have an effect on whether there's going to be the uptake of water or not after a flood.
Yes, of course. It is really important that we know the soil water condition so that we can improve our flood modelling. So if soils are really saturated, then we'd expect more water to run off over land, and that increases the flood risk. Similarly, if it has been really dry and soils become baked hard, then again that they can become more hydrophobic, so they actually repel water as the rain lands on the soil.
So actually, if you have quite a severe drought, that could increase the flood risk in a way. That seems very counterintuitive. Yeah, you wouldn't think of it that way.
Yes, and I think there are fairly limited studies on this, but it's really interesting how dynamic those soil properties are. You've got, some times when the soil is wetter, it can more readily absorb water, and as you say, it's counterintuitive that when it's really dry, it might actually repel water.
Our previous episode of this podcast was on wildfire, and we know we've had a particularly bad year for wildfires in the UK. Presumably soil moisture has an impact on the wildfire risk as well.
Soil moisture hasn't been used a great deal in the UK for wildfire risk, but worldwide it is a really important input into fire risk models, and I think increasingly it's going to become an important factor in the UK so that it's used in those wildfire risk models, and particularly where you've got more peaty soils with high carbon content and the soil itself can effectively burn.
Now, 2025, a relatively warm year, so I'm imagining soil moisture has been quite low, but what did your instrument, what did Cosmos tell you about 2025?
2025 has been an interesting year, obviously challenging for farmers and for water resources. We started off in January and February with really saturated soils, and the soils here at Chimney Meadows were as wet as any other winter really, and then in March the rainfall just really dropped off very suddenly and very sharply, and so those spring months we only had about 1/3 of the usual rainfall for that period. The soils really dried out very quickly during that spring period, and that's of course a crucial period for farming, for crop development and for cattle grazing as well.
We've then had a reasonable amount of rain. It was actually raining quite a lot yesterday when we're recording this. How quickly are we finding that the soil moisture is recharging, if you like?
I think when there is sufficient rain, particularly as with the techniques we're using here, we're measuring mostly the top 20 to 30 centimetres of the soil, so it's relatively shallow, so that is the more dynamic layer, i.e. it can respond more quickly to rainfall. So October's progressed and into November, you can see the soil moisture has recovered quite significantly, and we're probably quite close to normal soil moisture conditions now for this time of the year.
But thinking about the dry weather started in April, November's quite a long time for that process to happen. And in the area that I live, our hosepipe ban has actually only just been lifted. This recovery, it takes months rather than weeks, even if you have a lot of rain.
Yeah, and I think that's a really good point about 2025. I think the main story in terms of the drought is that long duration, that it started very early, really before the start of spring, just as winter ended. And it continued into autumn, mid to late autumn, before there was a significant recovery. So, yeah, it's that really long duration, and that, again, can affect farming in terms of getting winter crops sown.
You've got 10 years of data so far. What can you tell from what's gone before and what's perhaps going to be happening in the future?
Yeah, so we've done some interesting things. Colleagues have used our climate data that we have, historical data sets, to model the soil moisture at Cosmos UK stations and then see what it would have been like in classic drought years such as 1976. So we hindcast back to those years so that if we had have been measuring then, what would we have seen? And that really helps us to put our current data into that much longer historical context in terms of the statistics of the drought events and flood events as well. In terms of the future, we've done a lot of work now, again with colleagues, particularly working with the Joules land surface model, to improve the soil moisture representation in those models, calibrating the models using data assimilation techniques, which means that we're not just improving them for an individual Cosmos UK location, but for any other soil type around the country that matches that location. With this work, we've projected now using future climate projections, and this is based on more towards the sort of worst case scenarios, and we can show that by 2070 we'd expect drought events such as 2025, these longer duration intensive drought events, to be as frequent as every 2 to 3 years.
Oh my goodness, that's awful.
These are the more pessimistic projections. If we don't address climate change, and obviously the more we can do to reduce emissions and reduce global warming, we can still reduce that drought impact. The other use of that type of study, of course, is to plan to be more resilient as well.
It seems a shame to say this on such a beautiful winter's day with a blue sky by this quite impressive piece of equipment, even if you can't tell from the outside, that, you know, you're painting quite a grim picture. What do you hope will be done with this information?
The more we understand both the current conditions and potential future trajectories, we can actually respond as a country, as a community, if you like, and at the government level, so that we have the right investments in infrastructure. So we might need to think about things like new reservoirs, which of course are controversial in terms of taking up land. There are some difficult decisions, but there are going to be these future challenges that we need to address, and if we don't do something, then ultimately we might be in a position where we're struggling to grow crops, grow food and feed the country in terms of food security. But if we do look at the outcomes of these studies and we use that information, then we can actually invest sensibly now in future infrastructure to make the country more resilient to floods and droughts.
I loved that, using a different kind of rainfall, if you like, to monitor soil moisture, neutrons from space, not droplets of water from the clouds, raining down on an Oxfordshire field. And Sue, you got a chance to geek out over particle physics.
I did indeed. I was in my element there, in a field, out in nature, discussing neutrons and space. This weather station, it just looked like the sort of one you would see anywhere. And then to realise the science that's going into it and how it's measuring soil moisture is really quite wonderful. And I think it's a brilliant use of technology.
When you think it's going to be measuring neutrons from space, you imagine something quite flashy, but it was sort of just a long white tube.
You imagine Star Wars, geeky gizmo, sort of, shiny, but inside is what counts. And it's doing a very good job.
Absolutely. And do stay with us to the end, speaking of space, as we have a bonus item from Jon about how they're also using their cosmic ray detectors to understand space weather, solar activity that produces the aurora borealis or the northern lights, something that we're seeing a lot of recently in the UK.
But sticking with drought for now, Jon floated a sobering thought at the end of our interview that the more pessimistic projections of climate change show us having these long, hot, dry summers and intensive drought periods as frequently as every 2 to 3 years. Well, certainly there's a lot of agreement that the UK will be facing more of this so-called whiplash weather we saw in 2025. Hot, dry summers followed by, unfortunately for us, warm, wet winters.
And that makes monitoring what's going on more important than ever if we're going to manage these changes. Soil moisture is just one of a range of measures of drought, from the actual amount of rain that falls to water store levels and river flows. To get a better understanding of the bigger picture, we spoke to Lucy Barker, a senior hydrological analyst at UKCEH. I started by asking her if now, in the middle of quite a wet winter, was an odd time to be talking about drought.
No, it's not a strange time to be talking about droughts at all. Droughts start when we have a long period where we have less rainfall than we would expect to have. And that phrase, expect to have, is really important because it means that it's relative to the time of year that we're in and the location. Winter is a particularly important time because if we have a drier than normal winter, this can mean that we have problems in the following spring and summer because our water stores won't be as full by the end of winter as they would normally be, which means by the time we get to that drier spring, summer time of year, we don't have as much water in the bank as we might expect. This is especially the case in the southeast of England, where we're really reliant on groundwater for our public water supplies and to sustain our river flows. Groundwater responds to rainfall much more slowly than river flows or surface water. And so prolonged dry periods over winter can have significant impacts on summer river flows and groundwater availability. But in the north and western parts of the UK, we're much more reliant on those water stored on the surface, whether that's in lakes, reservoirs, and river flows. And those river flows, because there's less storage of water under the ground, they respond to rainfall much more quickly, whether that's a lot of rainfall or we have less rainfall, and those river flows drop very quickly. So we have what we call a flashy response, very quick response in the north and west compared to a much more subdued response in the south and east of the UK.
That's really interesting. Why is it so different?
It's all related to our geology. For a relatively small island, we have a lot of changes in rock types across the country, and the chalk that dominates in the south and east responds much more slowly. It can take several months to respond to the rainfall. It basically acts like a big sponge. It's storing and holding that water and releases it throughout the year into river flows, or can be stored and abstracted for public water supply, for example. In contrast to that, the north and west, the rock types are much harder. There's less space in those rocks to hold water. That's what drives those rapid or flashy responses we see in river flows. Water doesn't soak into the ground, it runs straight off into the rivers.
We've got this headline number of 90 for this episode because across last year, the UK had 90% of average annual rainfall. Now, to me, that sounds like, well, great. That sounds a lot. It's almost 100%. That's practically normal. But it has been a year of extremes in terms of weather, and it's often being called whiplash weather. So how do you view 2025?
So yes, 2025, hot, dry summer. People will remember their gardens will have really, really dry, brown grass in their lawns, in the parks. And what's interesting about that is the contrast with 2024. People, particularly in the southeast of England, will remember that was a really, really wet year. Around the Thames catchment and Severn Trent region in the Midlands, we had the third and the fifth wettest years on record. After that very wet 2024, we had a really dry start to the year, although that was maybe welcomed by members of the public. Obviously, for people in the farming community, that caused significant challenges when managing their farms, their crops, and dealing with their livestock.
It's interesting that you draw on that really different experience across the country. In 2025, in the southeast where I am, we certainly had that really dry period in spring and summer, and it feels like since then it's not stopped raining. But is that what happened everywhere in 2025?
No, it wasn't. And particularly in the west of Britain, we did see over the summer some quite wet conditions in Cumbria, for example, and the southwest of England. It wasn't dry everywhere the whole spring and the whole summer. There were definitely variations in those conditions.
Well, let's go to the water supply then now. We had those months of rain in 2025. We had this whiplash weather. Was there enough rain to top up the groundwater, the aquifers? I sort of wonder whether the reservoirs are now back to full capacity as we've entered 2026.
Yeah, rainfall for December was almost exactly what we would expect for the time of year. That meant that many of the river flows across the UK were kind of back to their normal, if not above normal conditions. And although this has meant that the stores of water in reservoirs have increased, some reservoirs were still below average at the end of December. And it's all to do with those deficits that have already accumulated or that we've gained over the previous months. We ended the summer below where we would expect, so it's taken more rainfall to get us back to a normal position. So going forwards, rainfall over the rest of the winter and into the start of spring are still going to be really important for our water resources this spring and summer.
Now, according to the Met Office, we've had 3 of the hottest years on record in just the last 5 years. Is that what it's going to be like from now on? Sort of more whiplash weather, effectively, going from extremely sunny, overly warm periods to really wet ones?
Climate projections do show that we're likely to get more of these extreme events. And thinking about how our river flows respond in particular, we've run the latest UK climate projections through a series of hydrological computer models to look at how river flows might change. And our analysis of this data shows that we should expect to see lower summer river flows and increasing drought severity. So in other words, the lowest flows that we see each year are likely to get lower. But exactly how much lower they'll get, we don't really know, and how severe those droughts might be is uncertain. And this is due to the uncertainties we see in those climate and hydrological models.
And this is where water security then is really important.
Yes, and that's what makes it really challenging and tricky to plan and prepare for the future when there are so many possibilities.
The other problem you can have with that is when you get these very extreme events, you get so much rain in one go, presumably that all runs into the sea, and then it's not those fresh water reserves that we need for agriculture or manufacturing or public water supply.
Yes, absolutely. That kind of those sequencing of the events or the distribution of that rainfall over the year can present significant challenges when we're managing our water supplies, whether we need to make sure we store enough water in our reservoirs, whether that's our public water supply reservoirs or kind of farm reservoirs, or whether we need to make sure there's enough space in those water stores to absorb excess rainfall to mitigate flood risk.
We touched on water security just now with the UK. If we widen this out globally and the drying up of water reserves across the world, something the UN calls water bankruptcy, what kind of threats does this bring with it?
One of the things that makes water so interesting to research, but also makes it difficult to manage, is that water touches every part of society and the environment. We're so dependent on it. And this means that information on how much water we have, how much water are we likely to have in the coming months and in the future, is really important so that we can try and manage our supplies better, make the plans now to be more resilient to future changes. Some of the work we're doing at UKCEH with the World Meteorological Organization is to develop a global hydrological status and outlook system so that we can understand across the world how much water we have now and how that might change in the coming seasons. This helps us fill in the gaps where there are not enough observations of things like river flow, soil moisture, groundwater levels, so that we have consistent information at the global scale on those water resources.
There's a project I work on, actually, led by UKCEH, called the Floods and Droughts Research Infrastructure Programme, or FDRI for short. It's a £38 million project using state-of-the-art sensors and new tech across the UK, which will help us understand how, when and why floods and droughts occur. And a big part of that is that observation element, isn't it?
Absolutely. And this programme is looking at the water cycle on a landscape scale, intensively monitoring parts of the water cycle across the whole landscape to understand where the water goes, to look at the water balance across 3 different rivers in Great Britain, the Chess, the Tweed, and then the Upper Severn. And some of the exciting things that FDRI is doing is looking at innovative ways to measure water flows through the landscape. So new sensors, new approaches, and integrating citizen science. So really taking advantage of that local knowledge and that experience and how that can be used to better monitor and understand floods and droughts.
Yeah, it's a really exciting project that will complement the long-term monitoring that UKCEH already has, going back in some cases to the 1800s. And I think the point around the water balance is really important. It's about understanding where that water is going. And as those extremes get worse, that's going to be more important than ever. But who's likely to use that information?
So our long-term data and the intensive monitoring data being collected from FDRI is being used by research scientists to better understand those processes and how water is moving through a landscape between soils, rocks, rivers, and things that are happening now and how they might change, how they have changed over time, as well as thinking about operational water management, things like flood risk assessments, public water supply, and water available for agriculture.
Now, just over a year ago, Alice and I went to the Cotswolds for a Counting the Earth episode. It was a day after really heavy rainfall. It was in an area in the Cotswolds which, often floods. One area had escaped the deluge, and that's because upstream there were all sorts of natural flood management resources. There were leaky dams, there were field corner bonds, and they trapped excess water and slowed the release into streams. There were ponds, there were trees. Is this a sort of approach that you might be looking at in the future, particularly to manage this sort of roller coaster of water cycling that's going on?
The complexity of the landscape and different needs of how we use that land mean that we have to use a variety of different tools and ways to manage the water. Nature-based solutions are absolutely part of that, so we can work with the landscape and not against it.
Lucy Barker. What I found really interesting about that, it's just a reminder in a way of the importance of geology when it comes to water resources and drought, because if you've got, particularly in northern areas, more dense rock, that will store less water, which means you then have to rely on more reservoirs. And then if you get a hot summer, your resources are more likely to be depleted. So it's that whole thing of how everything is related, and you can't just look at something like drought in one narrow area. You've got to consider so many other things.
Absolutely. And because geology is under the surface, we don't see it. And I don't think people necessarily remember it or think of it in the same way that you do rain, that obviously has a much more visible impact.
Yes, which is a bit more obvious, yes.
But that's why within the Floods and Droughts Research Infrastructure Project, for example, we've chosen those 3 river catchments because they are so different. So the River Tweed, for example, in southeast Scotland sits on impermeable rock that doesn't store any water. So that very much is a rainfall fed catchment. Whereas the River Chess, which is in Buckinghamshire in southeast England, that sits on those spongy, if you like, bedrocks. So it can hold a lot of groundwater, and that means that it's a bit more resilient to drought in terms of public water supply and things like that. It's important, though, not to just focus on the UK. This is a global problem. There might be quite big areas and big populations in the future that are left without water. And not only is that catastrophic for them, but it will also affect us because we rely on those places for our own food security. The food system is so interlinked now. And if there's a drought in Kenya, for example, we rely on them for things like broccoli and green beans, particularly out of season in the UK. So we may suddenly find that there are shortages of certain things, and that's going to have a really big impact on us as well as them.
Before we wrap up this episode, we still owe you a Cosmos bonus. That visit to a chilly field in Oxfordshire offered up a double treat. Not only did we learn about their innovative approach to measuring soil moisture, but Jon went on to tell us about a side project for the Cosmos UK network of cosmic ray detectors, turning their focus back up to space to record what's going on in the upper layers of our atmosphere.
It's really interesting that we have this free supply of neutrons that help us to measure soil moisture, but how many come to Earth each day, if you like, can vary depending on what we call space weather. So recently there was a big solar flare, what's known as a coronal mass ejection, and that can change magnetic fields around the planet and how many of the cosmic rays reach the Earth, essentially. Why am I telling you this? Well, we actually see these changes in our neutron count. So as well as measuring soil moisture, we do see these space weather events. So particularly when they're quite large events, because we have relatively small detectors. But what's really good is we have detectors across the whole country, and this can actually open up a whole new area of science where we're not only detecting the events, but actually looking at how they vary across the country.
And that's important, isn't it? Because at the moment we're going through what's called a solar maximum. So that's why low latitudes are seeing the aurora, whereas normally they're confined to, around the Arctic Circle. And there's an importance there. You mentioned space weather, because if you get extremely big coronal mass ejections, they can affect electricity supplies, power infrastructure. Are you working with the Met Office then, who are doing a lot of work into monitoring those coronal mass ejections as they come from the sun using satellites?
Yeah, so you're absolutely right. The importance of space weather is that it is at risk to national infrastructure, things like satellite communications, aircraft, aircrew, as well as possibly the power grid. And we have worked with the UK Met Office, who manage that space weather risk for UK government. And we also work with the University of Surrey Space Centre, and together we've already demonstrated that the Cosmos UK network can be valuable in that area of research.
I find that astounding. You think of the Northern Lights as this beautiful thing to watch, but actually satellites, the national grid, GPS systems, things like that, our entire country runs on those systems, and yet this weather that is happening billions of miles away can have such a big impact.
Yeah, it's kind of humbling in a way, and I think it's also interesting that as technology's developed very rapidly over the last few decades, we haven't seen too many of these large space weather events, and that's kind of important in the sense that our technology's got a lot smaller. We all carry around these wonderful computers in our pockets, but you can find that they're more susceptible to those types of space weather events because all the microprocessors have just got smaller and smaller, and they can be more sensitive.
Thank you very much to Jon Evans there for showing us around. Sue, you looked like you were in your happy place on that trip, talking about neutrons and solar weather and cosmic rays. You were positively glowing. It was quite cold, actually. Maybe that was just the cold weather?
It's probably a little bit of both, I think. Yes, it's not often I get to use my physics background in an environment story, but when the two collide, then I'm very, very happy. By the way, there are lots of apps that you can get. I have one that gives me a warning whenever there is basically a high level of seeing an aurora borealis in the UK. And quite recently, they were seen as low down as Cornwall. Can you believe it? But it's nice to know that a lovely environmental monitoring scheme has a dual purpose, but obviously the soil moisture is its main reason, and very impressive it is too.
You can look back on 2025 and realise what a roller coaster year it was. We had an incredibly dry spring, followed by 4 heat waves, and then a deluge across autumn and winter that saw the UK as a whole almost entirely catch up on our annual expected rainfall. And this led to our headline number of the UK receiving 90% of its average rainfall by the close of the year. It's a relief, I suppose, that our reservoirs, rivers and aquifers got topped up, but that so-called whiplash weather is little comfort to the farmers whose crops baked or drowned over the course of the year, or to the homeowners whose houses flooded when the rains finally came.
Yes, and as Lucy said, water touches every part of society, and a lack of it or too much at once can have serious consequences. Well, when we were talking to both Jon and Lucy, I kept getting flashbacks to previous episodes. We've looked at wildfires, natural flood management, salt marshes, the future of the crops we grow, and of course, using nature to mitigate the effects of climate change. And the thread through all of those episodes is water. And if you haven't heard some of those episodes, don't worry, they're all there in our archives. Really informative and will help you understand how everything is connected within environmental science.
Absolutely. There aren't really any barriers in the environment, and that's why it's so important that we study the environment as a whole. As we face more change and more uncertainty in our climate and so in our water cycle, it's imperative that we understand current and future water dynamics so that we can plan, prepare, and become more resilient to those future changes. Thank you for listening to our dive into drought. Please join us next time for another look at nature through numbers.